All right, so today we are going to start talking more about the zeros of polynomials. So you should have had time to put together your flip book. It looks a little bit like this. Pause the video as needed. So what are zeros? The points at which the function intersects the x-axis. Okay, so those are also like x-intercepts, okay? Sometimes they might be called roots, sometimes they might be called solutions. Just depends on the problem. A polynomial function of degree n can have at most n real zeros. So if a polynomial has is a function of degree 7, that means that we can have 7 zeros, or 7 different places where the graph will cross the x-axis. Will it always be 7? Not necessarily. We're going to take a look at when that not necessarily is true. So an even degree polynomial has an even number of zeros, or it could have no zeros. And we're going to talk about that no zero situation further down the road. And then an odd degree polynomial has an odd number of real zeros. And then we have something that are called linear factors. And the linear factors of a polynomial just reveal the zeros of that polynomial. And linear factors can be found by writing the polynomial in factored form. So right now we have this function f of x equals x to the third minus 2x squared minus 15x. That's currently in what we call standard form. What we want to do is we want to rewrite it in factored form. So the first thing we want to do with any type of factoring, we want to identify how many terms that there are. In this case, this polynomial has 3 terms. It's a trinomial. So think about how we factor trinomials. Before we actually factor the trinomial part of it, we want to look to see if there's a greatest common factor. And in this case, we do have a common factor of x. So we're going to take out that x, and we are left with x squared minus 2x minus 15. Now, inside the parentheses, we want to see if we can further factor that. So we're looking for a pair of numbers that multiply to give us a negative 15 and add to give us a negative 2. Well, that combination of numbers is a negative 5 and a positive 3. And then we're just going to drop down that x that we had factored out at the beginning, and we put our f of x is equal to. Or you might see a y is equal to. It's the same thing. Okay, so what are the linear factors? X is a linear factor. X minus 5 is a linear factor. And x plus 3 is a linear factor. Those are all linear factors. So let's go back to this idea of what do the zeros look like on a graph. So we're going to go ahead, I'm going to take a look at Desmos here. Oops, wrong Desmos. Hold on just a moment. And I'm going to type in this equation for number 1. Y equals, we have the quantity of x minus 1, and then the quantity of x plus 3. So let's take a look at this graph here. This graph is a parabola. Again, we can click on all of those little gray dots. That'll help us draw our graph. But the question is asking us to find the zeros. Well, the zeros are where the graph crosses the x-axis. So if we go back to our graph, we're going to graph this by hand. We have a value at negative 3, 0. We have a value at negative 1, negative 4. 0, -3, and then 1, 0. And that's our parabola. So again, where are we crossing the x-axis? Well, we're going to cross the x-axis at -3 and +1. Well, let's compare that to the equation. What do you notice? If you think back to that zero product property, if we take each of those binomials and set them equal to 0 and solve for x, we get 1 and we get -3. Coincidence? I think not. So let's take a look at example 2. We have y equals x plus 1, x minus 2, x minus 3. So where do you think the graph is going to cross the x-axis? Well, it should cross the x-axis at, well, if x plus 1 is equal to 0, then x is equal to -1. If x minus 2 is equal to 0, x should equal 2. And if x minus 3 is equal to 0, x should be equal to 3. Well, let's go on Desmos and let's take a look and see if we are correct. So we have the quantity x plus 1, the quantity x minus 2, and the quantity x minus 3. So right there, -1, +2, +3. Okay, so we'll go ahead and plot our points at -1, +2, and +3 on the x-axis. We still need those other points though to kind of help us with the skeleton of our graph. We've got a point up here at 0, 6, and then at 0.1, 6.1. And then we've got a minimum value over here at 2.5 and -0.9-ish. So right in there. And then we can go ahead and connect the points. So now let's take a look at finding the zeros by factoring. I know this is hard to see. This says x to the third plus 2x squared minus 24x. And because we want to find the 0, we're going to go ahead and set this equal to 0. Okay, again, we have 3 terms here. So first GCF, that would be an x. So we're left with x squared plus 2x minus 24 is equal to 0. Factor inside your parentheses. So that's going to be an x plus 6 and an x minus 4 is equal to 0. So what are the values of x? Well, there's an x out front, so that means x is equal to 0. X plus 6, that means x is equal to -6. And x minus 4, that means x is equal to a positive 4. Okay, number 2. We have x to the third minus 6x squared minus 16x. Again, we're going to set this equal to 0. Common factor is an x. That leaves us with x squared minus 6x minus 16. That's equal to 0. Got a trinomial here, so multiplies to give us -16, adds to give us -6. That's going to be a -8 and a +2. So what are the values of x here? Well, x is equal to 0. Then we have a positive 8 and a negative 2. Let's take a look at number 3. Oops, that one's not there. It's just x cubed minus 25x. So we're going to set that equal to 0. GCF here is x, leaving us with x squared minus 25 inside the parentheses. Okay, this is 2 terms here. So with 2 terms, you want to see, is it a difference of squares? Is it a difference of cubes? Or is it a sum of cubes? Well, this one is a difference of squares. And to solve a difference of squares, we take the square root of both parts. We do 1 minus and 1 plus. So the values of x here are 0, negative 5, and positive 5. And then example 4, we have x to the third plus 6x squared plus 9x. The GCF here is x, leaving us with x squared plus 6x plus 9. I'm going to set that equal to 0. Okay, inside, can we factor? What multiplies to give us 9? Adds to give us 6. Well, that's 3 and 3. So our value of x is equal to 0, negative 3, and negative 3 again. Okay, negative 3 came up twice. Do we have to write it both times? No, but we do have to identify that it occurs twice. So you can write negative 3 and then next to it put a little m2. That stands for multiplicity. And you'll see on the next page, we're going to start talking about multiplicity. We're not going to do that today. We'll talk more about that tomorrow. But you just need to recognize that you can write your answer that way. So either answer is perfectly fine. How can you check your work? Well, you can go back into Desmos. Let's just take a look at this last one we did. We had y equals x to the third plus 6x squared plus 9x. Let's take a look at the graph here. Where is it crossing the x-axis? Right there at negative 3. Does it say negative 3 twice? It doesn't. We're going to talk a little bit about what this means again tomorrow. And then x is equal to 0. So you can go back and you can check your answers for all of these to make sure that they match up. So for homework, you are just going to do a factoring review. Oops, looks like this review. You'll notice all of the odd problems I have done for you. So you have kind of a guide if you get stuck. You are to do the even problems. All right. Hope you have a great rest of your day.